What if I told you the reason metals shine, bend, and conduct electricity is happening inside everything you touch right now? It's because of a hidden ocean inside them, not water, but a sea of electrons. It's why your world works the way it does. Today we're diving inside matter to uncover the invisible forces that control everything around you. Welcome to Learn with Adeesha, where we turn complex science into something simple, fun, and unforgettable. Let's start with metals. Inside every metal, atoms are packed closely together. But here's the twist. Instead of holding electrons tightly, they release them into a shared space. Here's the interesting part. They move freely throughout the structure. This creates what scientists call an electron sea, a floating cloud of free-moving electrons around metal ions. These electrons are not stuck. They move freely throughout the metal structure, almost like a flowing sea. This is the secret to everything metals do. Electricity flows easily because electrons move so freely. That's exactly how your phone charges every single night. High melting points mean strong bonding. It's why giant buildings don't just break or melt under pressure. Malleable means they can be hammered into shapes without breaking. The electron sea acts like a subatomic glue. Ductile means they can be stretched into thin wires. Quick question, can you guess why copper is used for wires? It's because it's both ductile and a great conductor. So remember, metallic bonds. Yakkorked a sea of free electrons. This makes metal strong, flexible, and ready to carry power. Now let's compare three types of bonding: covalent, metallic, and ionic. Each one is a different dance of electrons. Covalent bonds are all about sharing. Atoms hold on to each other tightly to share their electrons. Think of it as a subatomic handshake. Pretty cool, right? Metallic bonds are the ones we just saw. Electrons float freely in that amazing sea. This is unique to metals. Ionic bonds involve a transfer. One atom gives and the other takes. This changes how materials behave in a major way. Now let's go even deeper. Right now, inside the metal in your phone, billions of electrons are moving like this. Pause and think. What holds you together? Intermolecular forces. These are the glue that holds atoms together inside a single molecule. They are incredibly strong. Intermolecular forces. These are the attractions between different molecules. They are much weaker, but they are why water sticks together. In simple terms, intra is inside the molecule, and inter is between molecules. Got it? Let's move on. Intermolecular forces come in three main flavors: London dispersion, dipole-dipole, and hydrogen bonds. First, London dispersion forces. These are very weak and temporary, caused by moving electrons creating instant charges. Even noble gases like neon depend on these temporary charges to stick together for a split second. Next, dipole-dipole forces. This happens because one atom pulls electrons more strongly because it has higher electronegativity, creating positive and negative ends. Just like magnets, opposite ends attract. It's happening inside polar molecules all around you. Which do you think is stronger, LDF or dipole? Finally, the strongest of them all, hydrogen bonds. But be careful, they aren't actual chemical bonds. Hydrogen bonds form when hydrogen is already covalently bonded to oxygen, nitrogen, or fluorine, and then experiences an attraction to a neighboring molecule. It only happens with those three: oxygen, nitrogen, or fluorine. This attraction is what makes water so special. These are the strongest intermolecular forces, but they are still much weaker than real intramolecular bonds. Remember that for the test. These forces explain the states of matter: solid, liquid, and gas. Can you guess which state has the strongest forces? In a solid, forces are strong, particles are locked in place. That's why your desk doesn't just flow away. In a liquid, forces are medium. Particles are closed but can move. This is why water flows and takes the shape of its container. In a gas, forces are very weak. Particles are spread out and fly wherever they wish, just like the air you're breathing right now. Here's the golden rule. Stronger forces mean a higher melting and boiling point. You need more energy to break them apart. Time for a quick challenge. Which substance has the highest melting point? NH3, neon, or MgO? Most people get this wrong. Pause and think. Ready? MgO wins. Why? Because magnesium oxide is held together by super strong ionic bonds caused by powerful electrostatic attraction between charged ions. And the lowest, neon. It only has those very weak London forces. It takes almost no energy to turn it into a gas. Let's summarize. Metallic bonds are in electron C. Intermolecular forces are the attractions between molecules. And remember, stronger forces mean higher melting points. You've just unlocked the secret of how matter stays together. Which force is strongest, ionic or hydrogen bond? Comment your answer, and I'll reveal it in the next video. Then tap like and subscribe to join our science squad. At Learn with Adeesha, learning becomes fun, simple, and powerful. See you in the next video.